Hello and welcome to another CS200 mini lecture on Chapter 8. Today I'll be talking about Chapter 8.3 and 8.4, and we'll look at some examples in BlueJ. Okay. So one of the big things that may be going through your head as we begin Chapter 8 is why bother with methods at all? Because everything we can do in a method, we can do in the main program. However, there's a lot of good reasons for using methods. Methods, first of all, allow us to do things that fit a specific purpose, and it makes our code look a lot cleaner. Let's go back to the first one, the specific purpose. If we have a calculation that we're making multiple times, or some kind of formatting we're doing, or some kind of manipulation of data, and that same process happens multiple times, it's a lot easier for us to do it in one place for a number of reasons. First of all, it's one place that we know where to go to if we have many people on the project. Second, if we fix it in one place on a very large program, it could be fixed instantaneously. But if, for example, we had calculations all through the program and it was 50, 60,000 lines, it'd be a lot of work to go back and find all the different places to change that code. You may not have been exposed to large projects until now, but large projects will probably be something you'll be involved with at some time during your programming career. So here we can see the code looks very clean. Here is our main, and it almost reads exactly like pseudocode, so it's easy to follow. So for example, even without looking at this code in a lot of detail, I can see that we're prompting somebody for the number of steps that they walked, and then we are doing a calculation, and then we can actually come up with the number of miles that they walked and the calories that they burned. It almost reads like pseudocode. So in this case, it makes it a lot cleaner for us to try to understand the logic that goes on. Okay, so this example, especially with the yellow highlighting, and again, this is taken from your textbook. If we didn't do this, say we did it all in one program, this is what it would look like. So you can see it's not as clean, and also it's not as pseudocode-like. So here we're doing things, we have a calorie calc, and then we have steps to calories, sorry. And just from the names of the methods and from how we're proceeding through our main, it's very easy to understand what we're doing. Whereas here, we can still decipher it, but it's not as clean. I hope you can see this and appreciate it. Okay. So with modular development, we want to try to break a program into separate modules. Just like I mentioned a few seconds ago, it's likely that one of the projects you're going to be on is not just you writing your own code, but you're going to write a portion of a large programming application. And when you do this, you're going to need to do modular development. So you're going to divide a program into separate modules. Now, in CS350, we talk more about this process, but you can just think about it as dividing something large into separate steps, much kind of like we do with pseudocode or writing an algorithm. We're taking maybe a top-down approach where we take a big problem and divide it into smaller nuggets that we can actually write code for. So modular development is going to be part of your life as you get to working on larger problems and working with multiple people. Even if you only work on it by yourself, modular development is a good process to follow. The second is incremental development. I'm sure you've heard of agile development and some of the others types of incremental development processes, and you'll learn more about these in CS350. But incremental development is where you write program and you test it, and then you check the result, and then you make modifications to it, and you keep making incremental development and adding things to it or making corrections as you go on. So incremental development is something that's a lot easier to do with modules than it is just writing a simple program that has one large segment of code. The third thing is it allows you to put stubs in. And stubs are ways to write out, for example, with incremental development, the process, much like pseudocode, and stub it, or in other words, not develop it fully. And then when you have time, you're going to finish off that piece of code. So it allows you to write stubs or dead ends in your code, but you're still able to proceed and write code for the other portions that you haven't yet stubbed. So here, in this example, they show a stub, okay? So calculate MPG. Of course, it's going to return the miles per gallon, but you see that they've actually put some kind of print line in there that says fix me. That's just to let you know that when this is called, it's actually not going to be a correct value. So the value 0.0 is returned. So you might be thinking, why even bother with this? Well, when you're writing the program, if we go down here to our main, you can see that what we do is we do our calculations after we prompt the user for input. We do our calculations and then output the calculations that we've made. And we might have done these other calculations here, but we haven't quite got around to making the calculations or using the math correctly. However, we don't want the program to crash. We just want to see, have we defined the right methods to do the right calculation? And by just returning a 0.0 here, until we get the answer right and we get the formula right, it will return 0.0. And this is just a way for us to proceed and allows the program to compile. Okay, so here's an example that they have us doing. This is one of those methods in which we write the program. I'm going to skip this for now. So you can see here they have an example side by side of one in which they have different methods and another one where they just have a single main. So single main is on the left-hand side of the screen, and one in which they use methods is on the right. It's useful to compare these. You can see it doesn't save in terms of amount of code given this example, but it's a lot cleaner to look through the code with the methods there on the right-hand side. So you can do multiple factors. And again, with calculations, it's important to get everything right. Here is an example of using one of those stubs. You have the fix me. You don't have to use that exact terminology, but it's always good to put a message in if you write a stub, just so you know that the calculation that you're getting is not actually correct. So you don't not fix it and submit it. Okay, so let's take a look at some code that I've written in BlueJ. And I've called this methods for fun. It kind of builds on what we did last. Let's see here. For some reason. Okay, so we have our main down here. And again, this is returning the square of a number. And in this case, much like your lab for this week, I'm using the random number feature. And I have to import Java util random. Notice the capital R. And what I do here is what main is doing is I've defined a bunch of different variables, and then I've set the upper bound of the random number to 30. And I'll explain why in a minute. So I'm getting 10 values that are returned, and I'm using an array called numarray to get 10 values, and I'm going to get a random number, and I'm using 17 as a seed. The reason why I use a seed here is because it makes it reproducible. So every time I run this with the same seed, I'm going to get the same random values. Of course, you can leave the seed out, and then it uses the clock time to use it to calculate the seed. So I want to get 10 random values that have an upper bound of 30. And the reason is I'm going to pass this to another method that's going to calculate what the square of that number is. Okay? And I'm going to do this 10 times. So I set a I equals 0, I is less than 10, because my array is of size 10. And num array sub I equals, and here's where I get the random value, and I pass it the upper bound. Now I could just put 30 in here, but I think it's a little easier because I have all the variables declared up above, and if I just need to change upper bound, and this is a larger program, I just need to change it in one place. So I call num squared equals compute square, and I pass it the value num array sub I, right? So let's just say for the first iteration through my array, num array gets next in upper bound 30, and it comes back with a 6. So num squared is going to hold the value of 6 squared, so it's going to be 36. Then we've written another method called isOddNumber. Now what isOddNumber does is isOddNumber is a Boolean. It's actually isOddMethod is what we're calling, and we're passing that squared value to it. And it's going to return whether it's 1 or odd or even. So what we do is we use that number and we do mod 2. And if it equals 1, of course it can only equal 1 or 0. If it equals 1, then we know it's odd. If we mod that number and it's 0, then we know it's false and it's even. So we just call it isOddMethod, and I did isOddMethod to distinguish it from isOddNumber, which is a variable. So that's going to tell us either true or false. So isOddNumber is going to contain a Boolean. We can see here we've initially set it to false, just like in the previous example. And so here we say isOddNumber if it's, and we have a variable called odd-even, which is just a string. It only contains one of two values, either odd or even. So if it's odd, we're going to put odd. If it's even, we're going to put even. Then what we do is we do a print, right? So we say whatever the value is, right? This is going to be our initial value, that's 6. Squared is, and then this is the result that comes back from the first method we called, which computes the square. So it's going to be 36 and is, and then odd even is going to either be odd or even. In the case of 36, it's going to be even. Okay, so, and I'm going to go ahead and run it. And let's see what the output is. Of course, it goes to a different screen. And this is what comes back. So 6 is the random number generated. Squared is 36 and it's even. 0 squared is 0 and it's even. Yeah, well, math majors, I understand. You can debate that later. 4, 26, 22, and so on. Okay, so we get 10 values. And you can see it actually works, right? So we can get the right values in the right method that we expect. Okay. So let's take a look at another variation of this called methods for fun. Oh, before I do that, I want to kind of show you an illustration of what happened here. So what we have is this class called methods for fun. And in main, we first of all get the number that we want, right? So we randomly determine that. Then we pass num to square to compute square. And then that passes back the number squared to main. Then num squared becomes num to check. So it's the same value, we just give it a different name. We pass it to the method called isOddMethod, and then that returns back a Boolean, isOddNumber, true or false. Then we do the manipulation to replace the Boolean with one of two string values, odd or even. we construct what we want to print, and then what's output is num to square squared is whatever the squared value is, and is odd or even. Okay, so this has main kind of driving these two methods to perform a specific task each and come back. Okay, so let's take a look at another method here called methods for fun2. Okay, in methods for fun2, instead of doing that check odd or even, what we're doing is we're actually going to do that inside of a method, right? So instead of returning a Boolean, why do that? It's a lot better just to return odd or even as a string instead of having a Boolean and then back in main having to convert that. So that's taking and making a refinement to our main to make it even more readable. Okay. So here, and I've commented out what we saw in the previous example, methods for fun. But here, if you look at the code that's not commented out, you can see it's pretty readable, right? It's a lot more readable now that we move that code, this code here, to its own method, right? So if we look at this, it almost reads exactly like what we would expect for pseudocode to be written. So we declare our variables, then we loop through 10 times, and what we do is we compute the square, and then we use isOdd method to get an odd even value. Remember that odd even value is something we had to do in a for loop inside a main, but we've moved that out to the method, and now we're only returning a string which has the word odd or even instead of true or false. Then we can just print out the values. So this simplifies, by using that method, it simplifies how the main looks. Now, this is a simple example, but just imagine what would happen if this was hundreds of lines of code. Moving this out to some other method makes it a lot more streamlined and a lot more legible. So let's go to methods with branches. And their specific concern here with methods with branches is that we can actually do things inside here to make decisions inside, and this might return a different value back, right? So in this case, we have eBay fees, and then we have our main down here. And inside eBay fees is where all the decision logic is happening with calculating that value. Now, what's nice is if we have other places in which we need to calculate this, it only needs to call eBay fees once. And then we return fee down at the bottom, and that's exactly what gets printed. Okay? It makes main a lot easier to understand and a lot more coherent. Okay? Now, can methods call other methods? Yes. So if you remember just now, we had something that looks like this, right? So let's do something like this in methods for fun3. Okay? So remember that compute square just calculates the square of a value we pass it from main. Now, what if compute square can call isOdd method, and then that can return odd or even, and then pass back a string to main to print? So the string is actually created before and outside of main. There's pros and cons to this approach, and I think the cons outweigh the pros. First of all, if we're printing this out and it's always going to be in the same format, it's kind of nice to do it this way, but it kind of makes main a lot less readable. So let's take a look at the code for methods for fun3. Okay, so I made some changes here. Let's compile it. Okay. close it. Okay, so let's take a look at the code here. So remember, what's happening here in our main, and I've commented out some things here, is we have our loop, and remember we're constructing what we print out, and we do this outside of main. What's happening here is we do compute square. So we're passing it num to square, so maybe that 6 value that we've randomly determined. We have to declare some more variables here, and because we can only pass back one value from the method, we've got to build a string with those values because we can't pass back odd, even, and the number to square. So we have to build the string inside of this method. The simple reason is because we can't pass back two values. Yeah, there's ways around it. We can build an array, but that's a lot of work. So here we do our calculation, num squared equals num to square times itself. Then odd or even. So here's where we call this method, which all it does is just return odd or even. And you can see here's where that branch is. So inside of isOdd method, we return a string. We're going to return either odd or even based on how the number, which is the squared value, mod 2, if it has a remainder or not. So what happens is we get either odd or even returned. We build our string inside this compute square method, and then we return the string back to our main method. But look at our main method here. We got our loop here where we're getting the random value, and then we're getting the string to print, but it's kind of hard to determine what's going on except for the fact that we're getting this string returned to us, and the string is magically going to have the values we want. So in this case, we've kind of over-modularized the code as opposed to made main the driver, which I would recommend. So down here, we print out a print line that gives us an extra line just to give a space, and then we have string to print. So let's see what happens. And again, I'm going to keep the old values from our initial run using the same seed, and let's see what happens. Okay, so when I bring up this value, of course it does a print line every time. So these are the original values. You can see that it's 6, 0, 4, 26. So by keeping that seed the same in the random function or method, you can see here that I get the same values every time I run it. Okay, so although I'm building the string outside of main, I'm building it in the compute squared method, it gives me the same result, except for the print line, of course, which I can take out very easily. But it's kind of hidden if I'm looking through my main and trying to determine pseudocode. Second of all, you can see that we can branch. We can have these conditional loops inside of our code in the method, and we can return values based on, so we can return this or return this. Okay, and of course, before we had Boolean, now we've changed it to string just because that's what we're returning. Okay, let's go back to the Zybooks. And their example is a little bit more simple than what we've done. And I encourage you to try these exercises. And again, they follow what we've done here. So again, just to kind of summarize, inside of methods, we can do branches and conditionals, much like we can in our main. And we can return different values based on what is calculated. And I do want to caution you against doing something like this, just because debugging it becomes very cumbersome. However, there are times when it makes a lot of sense to do this, and we'll learn this as the course progresses. Because, for example, We can get into classes that have different libraries of methods that can be called based on different values that we obtain. I'm hoping this makes it clear how much we can do with methods and also how important it is to make methods contain a lot of the logic that takes away from the pseudocode, all the details, like the devil's in the details, and allows main just to flow like pseudocode. If you have any questions or concerns, or you still don't quite follow this, please let me know. I'm happy to help. Okay, have a great day.